Hmm. So today we will talk about the Newton's law of gravitation. Do you know what is Newton's law of gravitation?
No. Yeah, we did. We did law of gravitation.
Hmm?
We did law of gravitation, yeah.
No, just don't see in your copy. Just tell me like this. If you know, then it's good. Otherwise,
Is it 6.67 times 10 to the power minus 11?
no, that is the value of g. Basically, that is not the law.
Yeah.
I'm just asking. Basically, the Newton's law of gravitation. Uh, I have told you in the last to last class that of this universe, of this universe, in universe we have a number of objects, like we have this pen, like we have this mobile phone, like we have human beings, like we have rockets, and all these things we have.
Mm.
So what happens? Basically, there is a force of interaction. There is a force of interaction between any two bodies of the universe. Any two bodies of the universe.
Mm.
Okay. So suppose if I am saying that, if I am saying that this pen has some mass, there will be some mass of this pen, and this is another object. This another object will have also some mass. Okay.
Mm.
So if two bodies have mass, if two bodies have mass, then there will be force of gravitation between two masses.
Mm.
Earlier, what we have done, Coulomb's law.
Yeah.
We have done the Coulomb's law, no?
Yeah.
So what was the Coulomb's law?
Two charges attracting each other
Hmm?
or repelling. Two charges attracting or repelling each other.
This was not the complete statement, I think.
Um, Let me check.
Okay, just relax. I'm telling. Basically, in Coulomb's law, I think you need to revise. Okay. So I told you if there will be two charges. Okay. That is why I am teaching with low speed. Okay. Because
Mm.
I know that sometimes the student uh, forgets things. Okay. Suppose there are
Yeah.
two charges. These two charges are very, very small charges known as the point charges.
Mm.
Point charges. And suppose the distance between these two charges is d. Suppose the distance between these two charges is d. So according to Coulomb's law, first statement of Coulomb's law, the force of interaction, the force between the two charges, you can say the force between two charges is directly proportional to the product of the charges. Second point, the force between the two charges is inversely proportional to the square of distance between them. Square of distance between them.
Mm. Okay.
This was the Coulomb's law. And finally, what we get? Finally, what we get? K Q1. Yes, I think in last class I have told you, no, what is force between
Yeah.
the two charges? F is equal to K Q1 Q2 into D square. And if there is any medium other than the air, then the value of the K is equal to 1 upon 4 pi epsilon 0, or you can say epsilon naught. Okay, this is the value of the K for air or free space. Air or free space. And if two charges are separated, suppose in any other medium can be any medium, like water can be the medium between the two charges, air can be the medium between the two charges, okay, oil can be the medium between the two charges. So for case when the charges are separated in a medium other than the air or the free space, then the value of the constant k is 1 upon 4 pi epsilon m. And what was epsilon naught and epsilon m? Epsilon naught is the absolute permittivity of free space or air. And what is epsilon m? This is epsilon m. In the last class I have told you what is epsilon m. Absolute permittivity of any medium other than air or free space. Absolute permittivity of free space. So absolute permittivity of medium. And we have done lots of question on the Coulomb's law. Now see what is the Newton's law of gravitation. Newton's law of gravitation. Newton's law of gravitation. Okay, see the Newton's law of gravitation. Suppose here is one mass, m1 is the mass. Here is m1 mass and here is another mass m2. And this is the line joining between the two masses. This is the line joining between the two masses. Earlier, we have discussed with charges. Now we are discussing with masses. So two masses are there, and according to the Newton's law of gravitation, number one, the force of interaction between two masses, is directly proportional to the product of two masses. Is directly proportional to the product of two masses. Number second, the force of interaction, suppose d is the distance between the two masses. D is the distance between the two masses. The force of interaction is directly proportional to 1 upon d square, means square is must be proportional to the square of distance between the two masses. Square of distance between the two masses. Okay.
Okay.
Okay, so now when you will combine, suppose this is your equation number 1, this is your equation number 2. When you will combine both the equation, you will get product m1 m2 divided by d square. Slowly I will increase my speed. Okay, slowly I will increase my speed.
Okay.
So here when you will remove this proportionality sign, we will get a constant g m1 m2 by d square. This is the final formula. And what is f? F is the gravitational force. F is the gravitational force between two masses.
Okay.
Between And this G is known as the universal gravitational constant. Means this value will remain constant everywhere in space. So this is known as the universal gravitational constant. And its value is 6.67 into 10 to the power G value
minus 11.
yeah, 6.67 into 10 to the power minus 11 Newton meter square per kg square. Newton meter square per kg square. Okay. Newton's law of gravitation. Okay, if I am saying that now I am just telling you the practical aspects of this. Suppose, for example, we have so okay, we have here. What is this?
Circle.
This is circle. Basically, this is a sphere, and I have drawn here. We are considering Earth as a sphere. So this is the Earth, and if Earth is a sphere, then there will be the center of the sphere also. There will be the center of the sphere also, no? What
Yeah.
happens? Suppose, and where do we live? On the surface of the Earth, no? We live on
Yeah.
the surface of the Earth. So suppose here is this object. This is any object. What is this? This is any body or object. This is any body. This body, if you will just compare size of me with the size of the Earth, if you will compare the size of me with the size of the Earth, the size of the Earth is much larger than me. Much larger than me. So if suppose small m is the mass of this body, so I am supposing capital M the mass of the Earth. So I can say this capital M is much greater than M. Very much greater than M, no?
Yeah.
Okay. Now, how here the Newton's law of gravitation will work? See here. This is the center of the Earth. This is the center of the Earth, and this is the body. So basically, this body is very small as compared to the size of the Earth. So basically, if we say this is the line joining between the center of the Earth, this is the line joining between the center of the Earth and this body, and this body. One thing I have not told you, but I will tell you. If this body is on the surface of the Earth and this body is not moving, we are on the surface of the Earth. Now, right now, where I am on the surface of the Earth, but now I am at rest. I am at rest. So what does it mean? This Earth is attracting this body towards this center.
Yeah.
Okay, na? So basically, this Earth is attracting this body with some force, and with an equal force, the body attracts the Earth. The body attracts the Earth Okay. And basically, so we can say uh, the gravitational force is always attractive in nature. The gravitational force is always attractive in nature. What about the force between the two charges? That can be either attractive or can be repulsive, but the gravitational force is always attractive. Okay. So so you can write here gravitational force between two bodies is always attractive in nature. Is always attractive in nature. Is attractive in nature. And Rayyan, see here. This force of gravitation always acts along the line joining between the masses. See here, this force always acts along the line joining between the masses, acts along the line joining between the masses. Okay. So this force always acts along the line joining between the masses. Now there is one more interesting thing that I am going to tell you. Very interesting thing. Suppose just a minute, I am taking one pen. Suppose for example, see here. This is the pen. Now this is very famous and I think you already knew it, but we will relate it with Newton's law of gravitation. So this is the pen here, and this is the it will be proper. See here, this is pen. This is very simple thing for you and for anyone. This can be very simple thing, but how we explain this pen is coming in downward direction. See here, like this. This is coming in downward direction. Can you tell me the reason?
Gravity. Gravitational forces.
Yeah, of course, the gravitational force. So basically, what is happening here? What is happening here? When you are studying a physics, na, so practical aspect you have to keep in mind. Practical aspect.
Okay.
So basically, this is the Earth. This is the Earth, and what is happening here? I am explaining this phenomena. This is the center of the Earth. This is the center of the Earth, and this is the surface of the Earth. See here, Rayyan, see here. See here.
Yeah.
You can write later. This is the surface of the Earth. So basically, initially, suppose when I take this pen above the surface of the Earth, when I take, this will be the pen. Suppose here, this will be the pen. Here, this is suppose the pen. This is the pen. Now this pen is above the surface of the Earth, and we know that there will be the force of attraction. There will be the force of attraction between the Earth, between the center of the Earth and the body, and that force is known as the gravitational force.
Yeah.
So that is why this pen is falling like this, due to the gravitational force. So imagine what is happening. Imagine, try to imagine. This is the pen. Basically, we are taking the pen above the surface of the Earth, and when I have dropped the pen, just I have dropped the pen, the Earth's gravity or Earth's force of gravitation attracting the pen towards the itself, towards the center of the earth. Okay, so that is why the pen falls and any other body falls.
Okay.
Okay, so are you making notes today?
Yeah.
Very good, very good. So have you completed this Newton's law of gravitation?
Yeah.
So I am writing just one more thing. If you are getting confused here, so I am writing because maybe you don't know. This statement means the force of interaction. The force of interaction between two masses is directly proportional to is directly proportional to product of directly proportional to their product. Their product. For this point, we can write. For this point, we can write. I need some space. Okay. For this, I can write the force of interaction. The force of interaction is inversely proportional to inversely proportional to square of distance between them, square of distance between them, square of distance between them. And what is F here? F is representing here the gravitational force. F is representing here the gravitational force. Gravitational force.
Okay.
M1 and M2, this is M1 and this is M2. M1 and M2 are the two masses. M1 and M2 are the two masses. D is the distance between two masses. D is the distance between two masses. So basically this formula we get for calculating the gravitational force between the two body or two masses. So this question I have taken from your assignment. This question. And we will try to solve this question. They are saying consider a space shuttle. They are saying consider a space shuttle which has a mass of about 1.0 into 10 to the power 5 kg. Means very large mass. Space shuttle, you know, no, space shuttle.
Yeah.
And circles the earth at an altitude of about 200 kilometer. Just you have to imagine the situation. See, this is my space shuttle. Okay, this is my space shuttle, and this is the surface of the earth, and now this is the space shuttle like this. And after a certain height, this space shuttle is rotating around the earth, and which is about 200 kilometer. Okay, rotating circles the earth means rotating around about the earth at an altitude of 200 kilometer. Okay. Calculate the force of gravity that space shuttle experience. Mass of the earth is mass of the earth. We have mass of the earth. It is not given here, na? So mass of the earth. I am writing mass. What is the mass of the earth? So basically, okay. So basically, we have two masses. What is happening here? Okay, this is this, and this is the earth, na? And there is one space shuttle which circles the earth. Okay, this is suppose the space shuttle. Circle. This space shuttle is like this. Okay.
Okay.
And mass of the earth is given, not given in the question. It is 5.97 into 10 to the power 10 to the power plus 24 kg. This is the mass of the earth. Okay. And this distance given as, they are saying at an altitude of about 200 kilometer. 200 kilometer. And what is the radius of the earth? Suppose this r is the radius of the earth. So basically radius of the earth is given by 64,000 I think kilometer. This is the value, na? Radius of the earth. Hmm. Hmm. Approximately we take it 6400 kilometer. Okay, 6400 kilometer we take. Okay, so tell me how many meters will be there in 1 kilometer?
1,000.
1000 meters. Okay, so this radius is 6400 kilometer. 6400 kilometer. Okay, so basically this is the center of the earth. So can we find the force of gravity between the space shuttle and the earth?
Yeah.
We will apply this formula simply. Now I will write it firstly. G m1 m2 divided by the distance between them square. Okay, so what is G? 6.67 into 10 to the power minus 11. M1, you can choose anyone, M1, any other M2. So basically this space shuttle has a mass of 10 to the power 1 into 10 to the power 5 kg. So here M1 I am taking a mass of the space shuttle 1 into 10 to the power 5 kg is the mass. And mass of the earth is 5.97 into 10 to the power 24 kg. Now tell me what will be the distance we will take for calculating the force of gravity?
200.
No. 200 plus 6400.
Huh.
Why? Because I have told you here, we will take the distance from the center of the masses. Okay? From the center of the masses we will take. Okay. So basically it will become 6620. So basically distance will be 6400 plus 200 means this distance plus this distance is the distance between the two masses. Actually we have to take the distance from the center of the earth. So this distance will become 6600 kilometer, and we can convert this into meter. So this will become 66. Do you have calculator?
Yeah.
Okay. 6600 into 10 to the power minus 10 to the power 3 meter. So we will put the value of d here. It will become 6600 into 10 to the power 3 and square of this. Okay, so we will solve it. So see here. So now don't use the calculator now. We will first calculate for we will do the first calculation for the powers. Okay, in the end we will see for the numbers. So here is 6.67. Okay, here is 6.67 and here is 1 and here is 5.97. 5.97. Now see the power calculation. This is 10 to the power minus 11. This is 10 to the power 5 and this is 10 to the power 24. So 24, this is plus power and this is plus power. 24 plus 5, 29. 29 minus 11. 29 minus 11. 18.
18.
Yeah.
18.
So it will become 10 to the power
18.
Okay. Now in denominator, see, this will be 6600. You will multiply it 2 times. So it will become 66 into 66 and 100 into 100 multiply. It will become 10 to the power 4 and it will become 10 to the power 3 square will be 10 to the power 6. Okay. Now what is this? This is 6, 4, 10. This is 10 to the power 10 and this is 10 to the power 18. So final power will be can you solve this now?
Yeah.
Let's try this. Calculate it. So it will be 0.009914 into 10 to the power 8. Okay, so it will become remove the point, it will become 1, 2, 3, 4, 5, 10 to the power 5. So it will become 914 into 10 to the power 3. Okay, Newton.
I got 9.14 times 10 to the power 5. That's correct.
That's also correct.
Yeah.
That is also correct because no, when you will write it like this 9.14. So here you will increase 10 to the power 2 means it will become 10 to the power 5 Newton.
Yeah.
Can you do the power calculation? Just let me check. Suppose this is the x and 10 to the power 5 multiplied by 10 to the power minus 8 divided by 2 into 10 to the power 6. Just tell me the answer of this, just fast.
-3.
Minus 3.
Okay.
This is 2, here 2 is also there.
2 times 10 to the power -3.
2 times 10 to the power minus 3. How can you say that? This is 1 by 2 basically, no? This is in division. See here. Here is 10 to the 5, 10 to the minus 8. It will become 10 to the power minus 3. And here is in denominator also, now you have to see the power. This is 10 to the power 6. See here. Basically, see. This is 10 to the power 5, 10 to the power minus 8. So it will become 10 to the power minus 3. In denominator, we have 2 into 10 to the power 6.
Yeah.
So this 10 to the power 6 in numerator becomes minus power. Means I can write this as 10 to the power minus 3 multiplied by 10 to the power minus 6 divided by 2. So it will become 10 to the power minus 9 divided by 2. And what is the 1 by 2? 1 by 2 can be written as 0.5. 1 by 2 means 0.5 into 10 to the power minus 9. So you can write it as 5 into 10 to the power minus 10.
Okay.
Calculation part. Okay, one more question. Suppose this is P. 10 to the power minus. This time I won't answer. 10 to the minus is 10 to the power minus 3. And here is 5. And here is 25. 10 to the power minus 80.
So will it be 2 times 10 to the power minus 28?
What you are getting? 2 times
10 to the power minus 28.
minus 28. Okay, we will check the answer. Now I am solving. This is your answer. So basically this is 10 to the power minus 8, 10 to the power minus 3. This will become 10 to the power minus 11 and into 5. Okay, and here this is 10 to the power minus 18. In numerator it will become 10 to the power 18. And here 5 5s are. So here will be 5. So basically I can write 1 by 5 into this is 10 to the power 18 and this is 10 to the power 11. So what will be the answer? 10 to the power 7. So basically you will get here 10 by 5 into 10 to the power 6. So you will get 2 into 10 to the power 6. See what this is the answer. And you are saying that 2 into 10 to the power. This power calculation you should know, otherwise these types of question not possible to solve. Power calculation is important. Just last question. This time do correctly. Try to do correctly. Okay. Think and don't hurry up. Okay. You can solve the question in 1 second also. You can solve the question in 2 seconds also, in 3 seconds. But initially, when you are learning something, initially, when you are at a learning stage, then try to understand the things, try to understand the concept with a slow speed. Slowly increase your speed. Okay, slowly increase your speed. Okay, another question. 5 into 10 to the power minus 19